Hi students, how are you? Today we're gonna talk about inflation decay. I started teaching this inflation decay last semester because I want the curriculum to be updated, focus on the concurrent issues that we care about it a lot. So we're gonna work on the key problem we have in our economy, macrofinance economy, which is inflation. Now, what's the macro aspect of it? Inflation is a macroeconomic quantity. What's the finance? The finance is simple. When you have high inflation, Federal Reserve raise the interest rate, then the demand for mortgage going down, businesses going down, stock market going down. So the inflation is one of the key players, key macroeconomic quantity that impact financial market. This is a classic example for microfinance, and I'm so happy that we start teaching this class in our curriculum and focusing on inflation. So what's you in the folder, you will see a folder, and you'll see a slides called measuring the decay rate. And what is measuring the decay rate? We know the inflation as of now, it's about 9%, maybe 8.7, went down a little bit. The question is, we are 8.7. The question, when we're going to go back to normal inflation, which is 2%. So we're going to do an exercise when we're going to go back to our normal inflation, 6 months, a year, 2 years. So if you work for Federal Reserve, and if you're the Federal Reserve chairman, if you are the Federal Reserve chairman, the first question is going to say, given what we have now, when we're going to go back to normal inflation. So what I'm going to teach you is exactly what the Federal Reserve does. Exactly. Maybe we are better than them. And I'll explain that later. Why we're better. So why we need to calculate the decay rate? The current inflation 9.1. The normal inflation is 2%. So the question is, when we're going to go back to normal inflation. Another example where we use a decay rate. Suppose the unemployment is low now, but suppose it's 10%. When Barack Obama was a president, January 2009, the first question said, what is the unemployment? They told him 10. And then Obama asked, when we're going to go to normal inflation, unemployment 4%? They told him, they did the same exercise we're going to teach you today. So the decay rate measures the time length for conversion to a steady state or normal economy. So here is econometrics methodology. It's auto-regression model, basically. But forget the big words and econometrics. We're going to simplify things to simple. We understand that. Inflation is CPI. Then inflation equal constant plus phi multiplied by the inflation loss period plus an error term. Now, if phi is equal less than 1, and then we are converging to the normal inflation. So that means if the inflation is suppose 9% and phi is suppose 0.5, then 9% times 0.5, 4.5, then the next inflation will be 4.5. Yeah, plus constant, but the constant. The more, whatever happened here, next period will be lower because phi is less than 1. Now, if phi greater than 1, then we are in trouble. That means inflation today cause tomorrow to be more inflation, like hike the inflation period next period, and next period inflation will be contribute to more inflation. That's when you have a hyperinflation, and there's countries like Argentina, they have a hyperinflation. This is what they have. Actually, their phi is greater than 1. When phi equal 1, that means the inflation is steady. 9% today is going to be 9% next month, and always 9%. When phi equal 1 or phi greater than 1, then the Federal Reserve have to be involved. They have to hike the interest rate, increase the interest rate. So what the Federal Reserve, that's the next model. Interest rate was 0 till March, by the way, March 2022. And then inflation reached 8%, 7%. The Federal Reserve was in panic. He said, I need to lower the inflation. When I say he, because Joe Powell, the Federal Reserve chairman. So what he said, I'm going to raise the interest rate. And when I raise the interest rate, if theta is below 0, then I'm going to raise the interest rate. So RT become to be higher. Theta is, if it's below 0, then that is going to lower the inflation because this is negative. If theta is negative, then the inflation will go down. If theta greater than 0, that means you raise the interest rate, but that when you raise the interest rate, the inflation going up because theta is positive. When theta equals 0, it doesn't matter. You raise the interest rate or you lower it or you whatever you do, it doesn't matter. It has no impact on inflation. You might think in your mind that is there a case where theta equals 0? Yes. In countries when the Federal Reserve or the central bank, they call it, print money, no, it doesn't matter. You raise the rate, you lower the rate, people don't care about it. You're in hyperinflation, you continue inflation. The Federal Reserve is useless. So what you need discipline, and what you need actually, you need theta to be below 0. That's a normal modern Western economy when you have a separation between the Federal Reserve and the government. So how are we going to estimate our model? I collect data from Fred. If you click on it, you will see the data, and I will show you now how I do it. We're going to estimate theta. If theta greater than 0 or equal, then no decay rate. And if theta below, then we continue. So if theta greater than equal 0, then there is no decay rate. What does that mean? If theta greater or equal 1, not 0, 1. If theta greater than equal 1, then no decay rate conversion. Let's go back here. If theta equal 1, that means inflation today will be multiplied by 1 equal, then will be the inflation for tomorrow. If theta greater than 1, that means inflation today multiplied by something greater than 1, higher inflation. So if theta greater than equal 1, then no decay rate. We're done. We don't need to do anything. You stop. You're going higher. You're not decay. You're going higher. If theta less than 1, then we continue the exercise. Then the decay rate, T month, will be the duration for inflation is like how many months to go down to 2% will be D star equal current inflation multiplied by theta to the power T. For example, the current inflation is 9.1. Suppose theta is 0.94. Then in 12 months, the inflation will be 4.5. So here's an exercise. The current inflation, which is truly last month was 9.1. Suppose 5 is 9.43. So the question is, in 12 months from now, what's going to be the inflation? Then in 12 months from now, the inflation will be 4.499. Okay, so that's the estimation time to optimal inflation or normal inflation. So we're going to call T star is the optimal inflation, and then D star divided by current inflation equal 5 multiplied to the T star. Taking a log, you will have this. T star equal log of D star divided by current inflation, everything divided by log 5. D star in this case is 2% because we want an inflation of 2%. So if you said my goal is to have a 2% inflation, given the 2%, given the current inflation multiplied by 5, you need to estimate. That will give you the T star. The T star, like T months, 5 to the power T star, given the current inflation will give you back to 2% inflation. Here's example. T star, that's the equation we're going to calculate. We want to calculate T star, which is the months till we go to normal inflation. In this case, D star equal 2%. We said inflation should be 2%. Current inflation is 9.1. Suppose 5 is 0.945. Then how long months it takes to converge to normal inflation? Then log 2%, divided by 9.1, divided by the log of phi, that will be 14 months. Then if it can say in 14.3 months, we will be back to normal inflation. Now, let's go back to this equation. Like T star is number of months till we converge to 2% inflation, which is equal log. D star is the ideal inflation, 2%, divided by current inflation divided by phi, log of phi. Now, log of phi, if phi equal 1, then log of 1 is 0. That means this number, whatever is this number, divided by 0, that means infinity. T star equal infinity. That means we're never going to converge to a steady state. So here, if phi is 1, that means you're going to have something divided by log of 1 is 0. Log of 1 is 0. Well, you're going to divide something divided by 0. Then this is infinity, like a big number. So therefore, we're not going to estimate this model. It's important here because we're going to do, because when I estimate the phi, it's going to be 0. It's going to be 1. So when the phi equal to 1, this equation doesn't work. When phi here, if we estimate that and equal 1, what is that phi? Here we go. That's a phi here. If phi equal 1 means no change in inflation. If the current inflation is near 2, then we are in a good place, steady state. Otherwise, you're never going to converge on inflation. So this equation works only when phi is below 1. So no convergence at all. When phi, what if phi equal 1? No convergence at all. D star equal this. 1 to the power T star, which is equaling current inflation. So D star, the inflation will be after T months, whatever months, it's going to be the current inflation. T star will be infinity. If phi equal 1, then infinity, the equation is unstable, and then we have that. What if phi greater than 1? Then with no convergence at all, we always go into hyperinflation. When phi greater than 1 or phi equal 1, then the Federal Reserve have to raise the interest rate. Then what? The Fed should continue hike the rates. So let me go back the theory, and then we're going to go to the empirical. So Federal Reserve says, wait a second, the inflation now 9.1. I want to go back to 2%. How to do that? How long is going to take us to go back to inflation, 2%? Well, you're going to estimate this model. We get the phi. Once we get the phi, then we can say the T star, if the current inflation is 9%, the goal of the inflation is 2%, we get the phi, then the T star will tell us how many months we are converging to a steady state. So now we're going to go and take the data. We're going to estimate the model and see what we have. So you have to go to Fred. Control Alt. Look in that. Okay, that's a Fred. That's a consumer price index. What we will do analysis monthly because the Federal Reserve look month over month. And then we're going to go download Excel. And open. So you will get something like this, Excel. So this is a price 21 all the way down. Price index going down. So the CPI will be equal. Well, the CPI for the month of January will be equal to the CPI. That's inflation basically of end of the month divided by last month minus 1. So that's the CPI. And then the annual inflation will be the following. So the annual inflation, if you are in January 72, then in December, it will be the sum of 12 months. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the sum of those, that's the inflation of that month. That's annual inflation. And we care about annual. Now, I'm not going to look to the 40s and the 70s and 50s data. I need the recent data. Okay. I know July was zero, the inflation in July. I know that. So I'm going to put that manually. So as of now, let's go for this to go June. If you want to just for sure, or go with this. So we didn't need that information. Delete the last one. Like no, undo. So I'm not gonna use this one. So we're gonna start from here. Now the question: how many months we need when we do estimation regression? How many months? 12 months, 24, 36. Let's say how many years now. Well, the answer is simple. The longer the sample, the more you give weight for the past and less weight for the current. The shorter for this of the sample, like from 2019, the last 3 years, then you give weight more to the years, recent years. Now we have to understand here, we have COVID, and after COVID, we have this. So we have not like clean example. So what we're gonna do actually, take example of 3 years, like 36 observation. So that will be 21, 20 COVID, before COVID, yeah, something like that. So if this is 1, months 2, we want a 36. Oh, we went too far. 36, 48. So between 36 and 48. I'm going to do the analysis for 36. And I want you to do the analysis in your homework for 48 weeks. So I'm going to estimate the model for 46, and you do it for 48. So this is CPT, the current inflation, CPI at time T. And this is equal this one. Enter. Or we can do like this, right click, copy, and do values instead to have equations. Because if you do equations, you're gonna have a trouble. You just do values. All right, that's CPT. CPT minus 1, CPT at T minus 1 is this, basically. You're gonna go all of those, copy, and we're gonna do the same, right click and values. And the last one, we have to take it. We have to take this one, delete. So notice, this is the CPT, this is CPT minus 1, CPT minus 2, CPT minus 3. So when the current inflation is 0.0174, the previous inflation was 0.18. Let's make it different color. Let's make it this. So now you can see it. That's too dark, maybe something less dark. This is something better. So this is the inflation today. This is the inflation last time. This is the inflation, and this is one before. So now we have a CPT, CPI inflation rate at time T and T minus 1. So what we want to do is simple. We want to do the current model. We're going to estimate CPIT as a function of CPIT minus 1. We're going to ignore the interest rate for now. T minus 1, get the phi. If phi less than 1, If phi less than 1, then we're going to calculate the duration to go back to normal inflation. We're going to calculate this model, which is T star, how many months is going to be to go to normal inflation. Let's do it. Boom, we're done almost. Just we need to regress this with that. So I need those for the regression to make it simple. I need to put them here. All right, so good. So this is my y basically, and the other one is my x. So you do file, options, add ends, go, and then if you go to data, here you need to add analysis toolbox, analysis this, do OK. And when you go to data, you can see something in the corner saying data analysis. You click on it. Obviously. And you go to something called regression. You do OK. And then they're going to ask you, what's your y? Well, that's our y. CPT, all the way down, that's our y. What's our x? Well, that's simple. Here's our x. CPT minus 1, all the way down. Remember, when I say all the way down, I clear the last one here. A lot of students, they have this not balanced. It should be balanced. All right. We get that. And then they ask you, do you have a labels? Yes, because we include the first column, the first row, sorry. It was CPT minus 1. Constant 0, no, don't touch that. Do OK. And that's a result. So what is that fee? That's a fee, 1.01. So fee equal, fee in this case, phi or fee equal 1.01. So how many months it's gonna take me to converge to interest rate to normal inflation? Well, the answer is simple. What's the answer? Well, here's the answer. What if phi greater than 1? No convergence at all. You're done. You're done. You go to the Joe Paul and you tell him we're not going to converge to interest rate because phi is equal or greater than 1. Just give you some idea about the results. R square reflect the fitness of the model. It reflects the fitness of the model. And it ranges between 0, perfectly not fit, perfectly not fit, and 1, which is perfectly fit. And in our case, 0.97 is awesome. It's very fit. Life is beautiful here. The T-stat reflects the significant, economic significant. So phi is greater or equal 1.01, which is greater than 1. Is it statistically significant? Yes. 34. If it's if T-stat in absolute value, if T-stat in if the absolute value, if the absolute value of T-stat greater than 2 or neighbor of 2, then you are statistically, then you say the results are statistically significant. So the Federal Reserve say, oh my gosh, phi is greater than 1. So if you tell Joe Paul, well, phi greater than 1, that means we're not going to converge. The first question Joe Paul should ask you, if he knows this stuff, or his advisor or staff, one of his associate, is the phi statistically significant? Well, you're going to say, yes, it's statistically significant. Then we are in trouble. Then you go to Federal Reserve, we go into hyperinflation. So what does that mean? Now the Federal Reserve have to go and hike the rate. Now, before we go there, let's assume phi equal, let's assume here it's not 1.01, equal 0.9, just for curiosity. So example, let's assume phi equal 0.9. Desired inflation is 2%. Current inflation is, let's assume 9%, 9.1. Then what is the T star? And the T star, we call it, let's make it in blue here. Well, it's going to be equal to log, we said current inflation, the desired inflation divided by the current inflation, everything divided by phi, by log of phi. But we didn't put the number, so we need to put the number. Phi is equal 0.9, current inflation 2, sorry, the desired inflation is 2, the current inflation is 9.1. Then the T star is equal to 14.3. That means in 14.3 months, we're gonna be in steady state inflation at 2%. The current inflation is 9. We would like to go to 2%, given the 5.9, then the 14.3 months will be in steady state inflation of 2%. Now, what if phi is in this case equal this number, 1.1? Then the T star doesn't make sense. It's a big number, -84. So that means look, there's no T negative in this case. So we're not converging. So therefore, there is nothing to do here. Just undo. This is we're done with the exercise. Now what I'm gonna do is that results here. Now we're gonna ask the Federal Reserve. We tell them, hey, dude, we're not doing good. We're going to convergence in our inflation. We wanna to hike the interest rate, RT. So we want you to hike the rate. So now we're gonna add to the model sorry here, RT. So we add to the model this RT. Now we know phi is greater than 1. The Federal Reserve have to be involved. That's a complete model. That's the one we're gonna use it now. So we need to collect data about RT. It's same. We're gonna go back to Fred, and we need to go something called effective interest rate, federal fund effective rate. This one. And we need monthly. You do download Excel and you open that. Open. And as I said, we're gonna go to the back to the end because this R doesn't help us. And let's see. We said 36. 1. Sorry, 1. Okay, we need to do this enable. One, 2, 3. So these are the last 48 months of interest rate. Right click. We go back to this one. And here are the 48. Right click, values. So that's RT basically. We need to keep it RT here. So this is the interest rate in the last 48 months. Now what we want to do, estimate the model with the interest rate. So we're gonna go back again. Data analysis, regression here. Okay. Now, what is our y? The same y, CPT. What's our x? It's gonna be different. Inflation last month plus the Federal Reserve rate. Yes. Okay. Boom. Results are out. Here's the result. RT, that means RT is negative. Negative is negative. So what does that mean, negative RT? When theta below zero, it mean when the interest rate is up, the inflation is down. Yes, we need that. Why? Now, the Federal Reserve say, wait a second, the more I increase the interest rate, the lower the inflation. Now, the question, how much I need to increase the interest rate? And the phi is again 1.02. So that means when we add the interest rate to the model, the phi went up a little bit, 1.01. Like when you put that, so that's a better model now. This is a better model. But what matters for us, why this is better model? Because there is a reason. Because R squared is 0.73 Fed involvement. Here, the 0.72, a little bit improvement, not a lot, but in both cases, the phi is positive, greater than 1. And here, the phi is still greater than 1. That means we are divergent, higher inflation like Argentina, or Argentina situation. But now, the Federal Reserve, if he hikes the rate, if Joe Powell hikes the rate, then the inflation will go down. Good. So I'm not going to calculate the T star here because we still have a phi greater than 1. What I'm going to do here is, if you want to lower the inflation, you need to get more rate hikes, Every month's rate, increase the rate every month. Now, your homework. I'm done, basically. Your homework is undo. No, do. Your homework, I didn't remember what's the number here, so I need to go back to Excel. $36, it should be 37. 213. Copy. What's your homework? Your homework is to get the numbers for CPTI and CPTI minus 1. In this case, CPTI is these numbers. With values. And then CPTI minus 1 without the gray number. And right click and with values. Good. And I want you to estimate the model, the phi and the theta, and gather your inference. Now, when you estimate, let me estimate this model to see what you've got. If you estimate this model, you should have data analysis, regression. Now our y is longer. And I'm gonna take this row here so I can get also the labels. And the x is also different. We have 2 x's. You have to make sure your labels check. No zero constant. Okay. So when you do the analysis, you will have these results. So I'm going to do undo. Boom. Undo. Right? Another. So you're going to get these results. I'm going to delete it. Yes. So I want you to take the data and estimate this model. Get the CT and CT minus 1, do it, estimate the model. Again, also, I want you to change this number to make it less than 1, like any number, put 0.8 and show me the results. Tell me, like, the current, if the current phi is 0.8, then in 6.789 months will be back to inflation, back to normal inflation. Just explain that to me. Put a number and say in 6.78, if phi is 0.8, then in 6.78 months, we're gonna go back to our normal inflation of 2%. Just say that to me. So I want you to put the data for 48 months, estimate the model and show me the results and the inference, and then go here, put any phi below 1, 0.95, 0.66, 0.3, whatever number you want, and explain to you what number you got. And there we have it. There we have it. We got everything you need for inflation decay. If the Federal Reserve is not involved, then we're not going to converge to interest rate, to inflation of 2%. So we need the Federal Reserve to be involved. And that gives you an idea about the good things about separation of Federal Reserve from government. And here's an example. 2 weeks ago, the unemployment in the new payroll and new job opportunities opening went up. 11 million people got jobs in the past few months. And that's a good news, actually. Strong economy we have. And Joe Biden went and he said, well, look at strong economy. But the stock market went 4% down when the economy was good. Why? The stock market doing the right thing. Why? Biden was happy. Everybody's happy. More jobs, less unemployment. Because the Federal Reserve is going to raise the interest rate. So every time you have a good news, that means more inflation. That means the Federal Reserve have to raise interest rate. Now, why you raise the interest rate, the stock market going down? Because when you raise the interest rate, suppose the interest rate is 20%, just suppose. And the stock market giving you 10%. Well, why to put money in the stock market? Go buy bond, buy the interest rate, get 20%, and don't buy stocks that give you 10% and volatility and this. So when the rate going up, the demand for stocks going down, bond become to be more attractive than stocks. So substitution effect, chicken burger, beef burger. So if people like chicken burger become to be cheaper, people eat less beef, and vice versa. Substitution product goods. Again, let's wrap up our example. And I'm happy with this example. Very concurrent, very important. We care about this. And this is a hot topic in the Federal Reserve table. We have a high inflation of 9%. We want to go to 2% inflation. The question is what the Federal Reserve has to do and when we will be in normal inflation. Well, if there is no Federal Reserve, this is the model we estimate. If it's equal 1, phi, that means inflation is steady. If phi is greater than 1, that means Argentina, we're diversion. And if phi below 1, that means we are conversion to a lower inflation. Now, if the phi greater than 1 or equal 1, then we're in trouble. The Federal Reserve have to be involved, increase the interest rate. When you increase the interest rate, if theta below 0, that means the more rate you increase, the less inflation, because theta is negative, rate is up, positive multiplied by negative is negative, then the inflation will go down. Then you estimate based on the phi. Here is example. If 5.943, the current inflation 9.1. In 12 months, how much inflation will be? Will be 4.99. Good. The question is, when we go back to normal inflation, well, if the normal inflation is 2%, if the normal inflation is 2%, the current inflation 9.1, and a 5.94, then a 14.3, that's example. We're going to be converged. If phi is greater than 1, greater or equal 1, then we're not converging to inflation. Our inflation is not conversion. So what I want you to do in your homework, it's simple to me at least, is this Excel, you're going to have it in the folder. I just want you to add the data for these two variables and then estimate the full model for 48 weeks. Sorry, 48 months. See what you've got and get the inference. Once you get the inference, also I want you to go to the result and change this phi to any number below 1, any number below 1, and tell me what the number here means. That's it. Thank you so much. I hope you like the exercise, and this is important. And happy class.